When an existing grounding electrode has a resistance to ground exceeding 25 ohms, an additional electrode is required as per the National Electrical Code, specifically section 250.56. The question arises whether it is permissible to connect this additional electrode to the first electrode, or if a new grounding electrode conductor must be run to the second electrode. The electrical code permits connecting the additional electrode to the first electrode. This means that you do not necessarily need to run a separate grounding electrode conductor all the way back to the service equipment for the second electrode. Instead, you can connect the second electrode to the existing grounding electrode system. This is often achieved by bonding the two electrodes together with a suitable conductor. The primary purpose of this additional electrode is to reduce the overall resistance to ground of the grounding electrode system. By connecting the two electrodes together, you effectively create a parallel path for fault current to flow to ground. The size of the bonding conductor used to connect the two electrodes must be sufficient to handle the potential fault current. The electrical code specifies the minimum size of this conductor based on the size of the grounding electrode conductor. It is essential to consult the relevant tables in the electrical code to determine the appropriate size. When installing additional grounding electrodes, it is important to consider the spacing between the electrodes. While the code does not specify a minimum spacing, it is generally recommended to space the electrodes at least 6 feet apart. This helps to ensure that the electrodes are in different areas of the earth and that they are not affected by the same soil conditions. There are several types of grounding electrodes that can be used for supplemental grounding, including ground rods, ground plates, and underground metallic water pipes. Ground rods are the most common type of grounding electrode. They are typically made of copper or copper-clad steel and are driven into the ground. Ground plates are flat metal plates that are buried in the ground. Underground metallic water pipes can also be used as grounding electrodes, but they must meet certain requirements. Firstly, the water pipe must be in direct contact with the earth for at least 10 feet. Secondly, the water pipe must be electrically continuous. Thirdly, the water pipe must not have any insulating joints or coatings. When connecting the grounding electrode conductor to the grounding electrode, it is important to use a listed connector. The connector must be suitable for the type of grounding electrode and the size of the grounding electrode conductor. The connection must be made in a manner that ensures a permanent and reliable electrical connection. It is also important to protect the connection from corrosion. This can be done by using a corrosion-resistant connector or by applying a corrosion-resistant coating to the connection. The purpose of a grounding electrode system is to provide a low-impedance path for fault current to flow to ground. This helps to protect people and equipment from electrical shock and damage. When a fault occurs, the fault current will flow through the grounding electrode system and back to the source of power. This will cause the overcurrent protection device, such as a circuit breaker or fuse, to trip, which will interrupt the flow of current and prevent further damage. It is important to note that the grounding electrode system is only one part of the overall grounding system. The grounding system also includes the equipment grounding conductors, which are used to connect the metal parts of electrical equipment to the grounding electrode system. The equipment grounding conductors provide a path for fault current to flow back to the source of power in the event of a fault. It is also important to ensure that the grounding electrode system is properly maintained. This includes periodically inspecting the grounding electrodes and connections to ensure that they are in good condition. If any problems are found, they should be corrected immediately. The resistance to ground of the grounding electrode system should also be tested periodically to ensure that it is within acceptable limits. As per NEC 250.53, A2, rod, pipe, and plate electrodes shall meet the installation depth requirements. Rod and pipe electrodes shall be installed such that at least 8 feet of the electrode is in contact with the soil. They shall be driven to a depth of 8 feet except where rock bottom is encountered. Where rock bottom is encountered, the electrode shall be driven at an oblique angle not exceeding 45 degrees from the vertical or shall be buried in a trench that is at least 30 inches deep. Plate electrodes shall be installed so that the upper edge of the plate is at least 30 inches below the surface of the earth. When multiple grounding electrodes are installed, it is important to ensure that they are properly bonded together. This can be done by connecting the electrodes together with a bonding jumper. The bonding jumper must be sized according to the electrical code. It is also important to ensure that the bonding jumper is properly installed and that it is protected from corrosion. In addition to the requirements for grounding electrodes, the electrical code also includes requirements for grounding electrode conductors. The grounding electrode conductor is the conductor that connects the grounding electrode to the service equipment. The grounding electrode conductor must be sized according to the electrical code. It must also be protected from physical damage. The grounding electrode conductor must be installed in a raceway or cable armor if it is exposed to physical damage. The electrical code also includes requirements for the connection of the grounding electrode conductor to the service equipment. The grounding electrode conductor must be connected to the neutral bus or ground bus in the service equipment. The connection must be made in a manner that ensures a permanent and reliable electrical connection. It is also important to protect the connection from corrosion. Grounding is a critical aspect of electrical safety. A properly installed and maintained grounding system helps to protect people and equipment from electrical shock and damage. It is important to understand the requirements of the electrical code and to follow them carefully when installing and maintaining grounding systems. If you are not familiar with the electrical code, it is best to consult with a qualified electrician. They can help you to ensure that your grounding system is properly installed and that it meets all of the requirements of the electrical code. Remember that electrical work can be dangerous. It is important to take precautions to protect yourself from electrical shock. Always disconnect the power before working on electrical equipment. Use insulated tools and wear rubber gloves. If you are not comfortable working on electrical equipment, it is best to call a qualified electrician. In summary, it is permissible to connect an additional grounding electrode to the first electrode, provided that the connection is made in accordance with the requirements of the electrical code. This is a common practice that helps to reduce the overall resistance to ground of the grounding electrode system and to improve electrical safety. Always consult the latest edition of the National Electrical Code and local amendments for specific requirements and guidance on grounding electrode systems. Following these guidelines will ensure a safe and effective grounding system, protecting both people and property from electrical hazards.